This is the DC motor tachometer. It uses an IR brake beam to measure the RPM of a hobby brush motor. When current is applied to the motor, a magnetic field is created. This current propels coils inside the motor and causes it to turn. The motor speed is controlled by a simulated voltage from a PWM pin. This pin is connected to a MOSFET, which controls a 9-volt power supply. When the MOSFET is enabled, 9 volts will be sent to the motor. Now, since the Arduino is unable to supply enough current to the motor, we have to use an external power supply. In order to create a simulated voltage, you must use a high frequency and a varying duty cycle. The duty cycle is the ratio of the time the signal is high and the time the signal is low. The duty cycle also dictates the voltage, or simulated voltage. For example, a 50% duty cycle will have a 50% voltage, and let's say 30% duty cycle of 9 volts will be an emulated 3 volts. However, this constant changing of highs and lows can sometimes cause problems. To fix this, you can use this low-pass filter. This will smooth out the voltage. Like most smoothing techniques, this uses capacitors. Capacitors are exceptionally strong at smoothing out signals. To control the duty cycle, we use a potentiometer and as a voltage divider. The voltage level will be read by an analog ping and converted to a value for the PWM. Once the motor is running, it will start tripping the IR brake beam. Every time the IR brake beam is triggered, a high will be sent to an external interrupt on the Arduino. Now, every second, a timer interrupt will be triggered, and the Arduino will total the amount of interrupts that happened in that second and do some calculations to find the RPM, or rotations per minute. Then the RPM is sent to an LCD screen as well as the voltage level and duty cycle.